All right, we're continuing on 6.2, and as a reminder, we've talked about left hand. I don't know if it's really called left hand, but sometimes they call it left, right, and midpoint Riemann sums. So those are super important, but also trapezoidal Riemann sums. Now, I could make you memorize this formula, and there's actually a formula embedded. Like some math people actually prefer the exact formula for a trapezoid. I'm not a big fan of that. I just like to say, okay, well, if you remember this formula for a trapezoid, by the way, the height is the perpendicular distance between the two bases. The two bases are parallel to each other in a trapezoid. Then it makes sense. So this person calls it a height of 2 units. I would typically say, okay, well, the width of them are 2. And what are the heights of the two bases? Well, it's the left, so f of 1 and f of 3. So it creates a trapezoid, and you're finding this area. So if I were tasked with this problem, what I would do is, again, I know the formula, and the formula is easy for me to remember because I just remember it's half of the width, and then you add the two heights together. So that first one would be 1/2. The width of the two bases is 2, and then times f of 1, because that's the height of the left side, plus f of 3, that's the height of the right side. And then just to change colors, you would do this again from f of 3 to f of 5. And I think you could see in my work here that I'm limiting, I'm cutting off quite a bit of empty space. We're getting a pretty good approximation. And again, the formula for the trapezoid is 1/2 times the width or the height of the trapezoid, and then times you add f of 3 plus f of 5 now. And just to change colors one more time, you do it again because we wanted 3 trapezoids. Something like this. So 1/2 times the width, which is the height. It might help you to see that it is a perpendicular distance to the two bases that are parallel to each other. Yeah, f of 5 plus f of 7. And just like what I did in the first video, I don't have a calculator with me, so I'm going to jump to the answer key. And this is actually the formula that they use, where they factor out the 1/2 times 2. So if you open up a calculus textbook, you'll actually see them do this. And what you'll see is that f of 3 is repeated twice. So if you open up a math book, what you'll actually see, and this only works for equal iterations. The iteration would be like the distance from 1 to 3, the 3 to 5. I mean, sometimes I call it iteration, sometimes I call it interval, where f of 1 only happened once because it's only one of the bases, whereas f of 3 happens twice because f of 3 is part of the left trapezoid and part of the right trapezoid. And then it's 2 times, so on and so forth, until you get to the last one where that f of 7 only happens once. I don't really like teaching the formula, which is why I just stopped at showing you the work, I guess, and you get that 38.66 repeating. And so as you look through, you can try approximation number 10 on your own, and you can actually see that we're pretty much getting rid of all of that empty space. So we're getting a very, very close approximation. So how many trapezoids would it take before you get an exact one? I would say almost, you'd have to get in an infinite, I would say. Just keep going and going. I would not encourage you to memorize this formula. I would encourage you to remember that 1/2 times the width of each rectangle, which is this times 1, and then actually find each individual piece. But that's just my suggestion. You don't have to do it my way. So just real quick, this guy finishes up the notes and gets you to I guess, approximate. Do you think it's an over, under, based off of the rectangles and where they're located, and how much empty space does the empty space underneath make up for the over approximation that you got, where the rectangle's above, things like that. And this is just, I guess up to people. What you think. What do you think? And this is just what he has. So I'm going to let you pause it, and you can write out your things. But what I'm actually going to do, I'm going to work through this work that's over here on the right. And what you're going to identify is that you can actually use the antiderivative to get the exact answer. You can get the exact area by using calculus. And this is not a proof by any means. And you don't have to know the proof. Your calc teacher, professor in college might ask you for the proof. That's beyond the scope of AP Calculus, though, so I don't have to. Let me work through this for you. So if you're going to copy anything from the answer key, now's your time to hit pause. So if we go back to that problem, and I asked you to do the integral from 1 to 7. This is called the definite integral, by the way. I already forgot what the function was. It was negative 1/3 x squared plus 2x plus 5. Just double checking I copied it down correctly. And it would be nice if I put in parentheses. So what you do is you take the antiderivative of that, which I'll just work through. I'll imagine you can do this on your own. When you divide by 2, those cancel. And you leave off the plus c. Because it's a definite integral, we no longer have to worry about that plus c. Because all we care about is the area under the curve. We don't need to shift up or down at all. So now what you do is and this is just notation, this is how we write this, from 1 to 7. And what you do is you plug in 7 in for all of those x's. Should I put parentheses there? Figure out what that answer is, and then plug in 1 in for all those x's, which is really nice because 1 to any power is just 1. And then, times 5 is 5. And then you subtract off those two values, and you can use a calculator. So I would not expect you to know 7 cubed. But based off of looking at the answer key already, the exact area under the curve is 40, which is really, really neat stuff when you actually see the proof on why that's the case. So we can also be asked to do these problems, although I don't like this problem. This should not say the midpoint sum. I really, really don't like this, the way this author wrote this problem, because what's the midpoint between 0 and 7? 3.5. 4 is not the midpoint. So I cannot do this problem this way. I can't do that. And if you're saying, well, how did you know it would be between 0 and 7? Well, it says 3 subintervals. So from here to here. So I can't do this problem because 4 is not the midpoint of 7. If it were, if this were 8, and then, I don't know, this would have to be 16 to make that 12. And then this would have to be 24 in order for that to work. So I think I'm just going to share the answer key because this is, let me change these values. Let's make this 8. Let's make this 16. And let's make this 24. Now, 4 is the midpoint between 0 and 8. So doing it this way, my width of that first subinterval is 8. The height is the y coordinate, would be 6. And then the next width from 8 to 16 is another 8. And then the y coordinate of that would be negative 10. And then the width from that 6 to 24 is another 8. and that y coordinate for f of 20 is 8, and then you can work it out. So that would be 48. Well, what probably most people would do is factor out the 8. So then you can do 6 minus 10 is negative 4, plus 8 would be 4. So this answer should be exactly 32. Now, they don't have to be equal subintervals. I think that's the point this person was trying to do. I do the right interval from 0 to, I'd have to change this number too, from 0 to 24. So I definitely had to change this problem around. This is a poorly written problem. Ugh, I'll just put an X through it. I meant to revise it before, but sorry. Okay, let's do 0 to 15 now. So 0 to 15, and we want 4 subintervals. So I'm actually going to use, this is a good problem. I'll put a little check mark. This is a good problem. 1, 2, 3, 4. All right, so what's the width of the first rectangle from 0 to 4? That's a width of 4. Now, which height do I use? It's a left Riemann sum. So between 0 and 4, 0 is on the left of 4, so you use 15. I'm really hoping this is making sense. So what's the width from 4 to 7? That would be 3. And I use the left. That's why we say left, 6. And then from 7 to 12 is 5. And we use the left, which would be negative 5. 12 to 15 is 3. We use the left. And you can definitely do this math in your head. 60, 18, negative 25. I say it and then I almost make a mistake. Minus 30. And I always second guess my math abilities. And because this is a video, I want to make sure I'm doing this right. So this is 23. Just want to write down the negative 31 and 97. Just in case I make a typo. Because I could do, I'm just double checking, you know. Like if I did this first, I'd look at that. That's negative 7, and here is 30. 30 minus 7 is 23. So that's good. Moving ahead to the next one. It's more important. This is the 7/8 rule. Notice that there's 1, 2, 3, 4, 5, 6, 7, 8 numbers. AP calculus readers are taught that if 7 of these 8 numbers are correct, they'll give you that point, even if you're off. You know, because it's very easy on a no calculator to get this wrong. So anyway, so now we're going from 4 to 20. We want 4 subintervals again, but now we want to write Riemann sum. So we're looking at these numbers because those are on the right side. But all the math is pretty much just the same. 3, because that's the 4 to 7 is a width of 3. Use negative 5. 7 to 12 is a width of 5. And it's negative 10. And then 12 to 15 is 3. This is negative 2. And then 5 times 8. And if it helps, you can go ahead and graph this. And I guess I should mention, so 0, 15, 4, 6, 7, negative 5, is as you find these areas, if you're below the x-axis, we'd consider this a negative area. I know that sounds weird because I said area, and area is always positive, but it takes on a negative value. So when we are below the x-axis, we are negating. So it is possible to get a negative area. And that's a poorly phrased word because area is positive, but it's giving, just like velocity can be negative, the integral can be negative to denote, you know, which direction that we're going. So I should have mentioned that a long time ago. And then again, I need to hurry with this last one. For this, the 3 subintervals, the trapezoidal is fine that these are wrong values. You know, they're not evenly spaced out. The midpoint's the one that's the most important. Is 1/2 the width from 0 to 7 would be 7, and then you add your heights together, 15 plus negative 5. And we're considering these ones. 1/2 times 8, I'm running out of time, negative 5 plus negative 2. And I ran out of time.